Hi, welcome to clickmyproject.com. The project titler, Adaptive Workload Prediction of Grid Performance in Conference Windows. The abstract of this paper is that Grid enables a parallel workflow in the conference windows. There will be n number of systems, n number of works will be split to the n systems, and the work will be allocated randomly in the case of in the basis of CPU memory and memory allocation like that. But it is difficult to predict the workload in all systems in case of large tasks. In a sense, if a task is higher, then it is difficult to predict the workload. Suppose in that cases, as error is much easier and is not easier to find that. It is difficult to find that error. So long execution of workload, which gives the performance reduces in the conference windows, and heavy load fluctuations. Load fluctuations is possible in case of large workload in the conference windows when task is higher. To overcome that, we propose a polynomial fitting algorithm for CPU workload prediction in the conference windows. When the work is allocated in a system, we have to calculate the CPU and memory capacity based on the polynomial fitting. After allocating the CPU workload prediction, we have to find the mean square analysis in the basis of adaptive EMAF, that is estimation based adaptive filter algorithm. Existing of the paper is that workload prediction is based upon Kalman filter, but based upon some assumption, the workload prediction were calculated which is not efficient. Now let me see about the data flow of this process. First of all, creation of grid resources in the environment. First of all, we need to create some resources in the grid environment. We have to initialize a job which is present in the grid. We have to create some history in the grid environment. Based upon the history, we have to calculate the prediction based upon the jobs and the users in the allocated resources. After calculating the resources, we have to find the error difference. If the error difference is not there, the job will be allocated. If the error difference is there, then we have to go for error difference value. We have to calculate the mean square analysis based upon the EBAF method to minimize the error. After finding that, we have to allocate the grid job, that is gridlet means jobs, in the adapted resources. Finally, we have to find the benchmark evaluation. Now let me see about the process of our project. Here first we have to run the grid.java. Initially we have to create some resources like grid resources here. Then we have to in the create job. So 10 resources has been created. So each resources we can see for each machine we can know the machine ID and process environment. Later we have to click submit. Initialize for jobs and users. It is for history creation. Based upon the history only, we are going to calculate the grid workload prediction, and it is the history which has been created here. Then after that we have to click here, and we have to create job. Then we have to create users and the jobs. Click create users, and we have to initialize jobs, and we have to allocate the jobs for the users. So number of users will be 10, and we have to enter users and the jobs. Among 10 users and 10 jobs, I'm going to allocate the users and the jobs. 10 users were selected and 10 jobs were allocated for 10 users, and we have to calculate the execute time. After the data value has been stored, then we have to select one file. Initially what we have chosen is a trace here. Similarly, we have to add here. So available resources are up to 6 resources. So and when you click here, so only 3 resources were available for when this file has been allocated. And we have to click the true value, and predicted value here has 0. Let us try the value. So click store. We have to check whether minimization method. So we have to see proceed error minimization method. It means that predicted output is much lesser when compared to true value. So when this job has been allocated resource ID 0 means the workload prediction time will be 201 seconds only. But if we allocate the same job here, means 622 value has been selected here. It means that higher time value. It means that we have to proceed for error minimization method. Then we have to see for the same ID. Have to click prediction error. Prediction error is 421 seconds. Then we have to click add. Click 0. Resource ID 0. We have to search for CPU usage. Then we have to select the file which has been given here. We have to calculate the estimated resource. So adaptable resource has been selected here. So adaptable resource means, so 0, instead of 0, click 0, click process, then click 1, click process. So adaptable resources, 0 resource 10. So for example, instead of allocating the same job in the resource 0, we can, if we allocate the resource same job in the resource 10 means it is much easier to predict here. So number of users 10, then error so allocate job, we have to allocate error minimization, so there is no error difference, so process has been executed. So input data has been selected, we have to show it as execution as a benchmarking. Finally, my results were shown as benchmarking. So initially, when I allocate the job in the resource 0 means my workload prediction is higher, my delay, that is delay will get increased and performance get decreased. But here, if I allocate the same job in resource 10 means my delay, then my performance get improved. Similarly, I have to see for different values here, and I'm going to compare those results with two type of benchmarking, micro benchmarking, and these are the matrices available here. Similarly, link back benchmarking. Thank you for listening the process. Thank you.